Hello, welcome everyone. This is Shreyas here, and today we are going to conduct the flash drills discussion session on work and scalar product as well as energy conservation. In my previous sessions, I have discussed the theory, I have given you the definitions, the formulas, and also we have solved some problems like we usually do in our evening sessions. And in the morning and the afternoon sessions, we discuss the assignments which are called as drills, and these are proper discussion sessions, unlike where you just get the answer key or just a small solution. We are going to discuss every bit in detail. Alright, so please remember, this is a recorded session, it's a premiere video on YouTube. That means you'll have to help each other out, and all the new members in the family, welcome aboard, and all the old members, all the JEE enthusiasts who are already in our channel, please help and assist the new members inside our family. Alright, so this is a brief introduction about me. I'm Shreyas and I have been teaching for quite some time, and believe me, if you just follow whatever I'm going to tell you, you can be one of those students just like the ones whom I have mentored and who have excelled in their studies and who have got into IITs, NITs, BITS, you name it, most of the top prestigious institutes in India. Alright, so having said that, let's also remind ourselves that we should subscribe to this channel. Alright, because if you do not subscribe and like this channel, then you will not get the new videos, updates, and whatever new information or whatever press releases happen, or if there is some important thing, and even the discussion sessions, all these things will be missed out completely by you if you do not like and subscribe our videos. So do not forget to do that. Okay, so tonight, remember, we'll be doing potential energy curves, maxima, minima, which are a part of derivatives application. So we have done derivatives and integration before this. In case you have missed that, I would strictly recommend you to watch those derivatives related sessions. It will be there inside the playlist of one dimension motion. Alright, so watch that for maxima and minima, that will be needed. And we are going to extend energy conservation, and we are going to see all about PE curves as well as power in tonight's session, which will be conducted at 7 p.m. Alright, so let's get going. This is our first question. There is a shell which is fired in the air at some angle from the ground. On reaching the maximum height, what do you think will happen? Now, if this is the hill and you're firing the shell into the air at some angle, let's say like this. Now when it reaches the highest point, alright, so when it reaches the maximum height, understand the velocity is not zero. In fact, if this velocity was u and if this angle was theta, then this velocity is always u cos theta, because acceleration due to gravity is downwards. It cannot affect the horizontal component of the velocity, so that velocity always stays. It's only the vertical component that becomes zero, y component. So is the kinetic energy going to be zero? Obviously not. Its kinetic energy is not equal to zero. That option A is correct. Option B says its kinetic energy is equal to zero. That is wrong, of course. Its potential energy is equal to zero. Well, potential energy depends on which point you take as zero. Alright, you can take this line as zero potential, you can take this line, you can take this line. It's totally your choice. So saying that potential energy is zero is wrong. Maybe zero. It's completely up to you which point you want to take as zero potential energy. Both energies are zero. Obviously this is wrong. Hence the only correct option is option A, and that would be the correct answer to this question. This was quite easy but quite conceptual at the same time. Let's go to the next objective question. It says the work done by a conservative force. Now remember, conservative forces are those forces whose work done does not depend on the path. That's very important. And also, if you come back to the same point, the total work done is zero. So that is what conservative force is. Alright, so let's show some random points and see what is happening. So from A to B, okay, so from A to B, 100 joules of work is done. From path does not matter. Remember, it's a conservative force. So for conservative force, the work is not dependent on path. Okay, so I have very little space out there. So it's not dependent on the path. Next, from B to C. So C could be some point, let's say here. So from B to C, how much work is done? Minus 20 joules. The question is, what will be the work done by the same force from C to A? Now, think about it. In this entire journey from A to B to C, what was the total work done from A to B to C? I believe it is 100 minus 20, which is just 80 joules. Now, in our return journey from C to A, path again does not matter. Think about it. The total work done should be 0, because not just is the work independent of the path, but also when you come back to the same point, like gravity or spring, when you come back to the same point, the work done by gravity or spring like forces is always 0. So if you have done 80 joules work here, you should have done minus 80 joules of work in this path. So the total work done in that closed path, so total work done when you come back to the same point is going to be 0. That's how you can do it, and that's very easy to understand now. I hope this is clear, and that's why the correct answer should be option D, which is minus 80 joules. That's the answer. Okay, so that's option number D. Let's go to the next one. It's based on vectors. There are two forces, F1, F2. Please keep in mind that it's very important when you attend these sessions, you have already looked at these questions. These are not problem solving sessions where I'm giving you a problem, I'm giving you some time and then you are solving it. No, I have already shared the PDF assignment, guys. So in case you are new, let me tell you that you have to download those PDFs. You can download it via either Telegram or via the description box, alright, in the session videos. And then when you download it, solve it, attempt it. Don't worry about the answer, it could be wrong. Try it out. You can discuss amongst yourselves, it's okay. And then finally attend this session to get to know the correct answer as well as the method. Now, forces are given. Initial position, final position is also given. What is the net change in kinetic energy? Now, since the question demands us to find net change in kinetic energy, so remember, final kinetic minus initial kinetic is the change in kinetic energy. And have we not studied a theorem for change in the kinetic energy? What is the change in the kinetic energy? It's the total work done by all the forces is the change in kinetic energy. So what do we have to find? You just have to find what is the total work done. And how do you find the total work done? Very simple. Just find what is the total force. Yes. And then just take the dot product with the displacement. Okay. So I need to find the net force. Okay. How do I find the net force? Just add all the forces. So that's okay. But how do I find the displacement? Well, remember the definition of displacement, guys. What is the definition of displacement? Yes, it's a straight line joining initial and final point. That's okay. But also, isn't it final minus the initial position? So whatever is left over is always the displacement. So it's, remember, final position minus initial position. So that is nothing but displacement. So keep this in mind, and now we'll try and solve the problem. First, let's talk about the forces. What is the net force? We can do this orally. F1 and F2. So there is 2i and there is minus 5i. So 2 minus 5 is going to be minus 3i cap. Okay. 4 plus 7 is going to be 11 j cap. 6 and that 3 is going to be 9 k cap. Okay. So that's what it is. Next, displacement. Now displacement is nothing but, remember what did I say? Final minus initial. This is final and initial is here. So final minus initial. So you can do this mentally. I don't have to do it because you're not kindergarten kids now. So 20 minus 10, how much is it? It is 10 I cap. I'm just using this definition. And 22 minus 12 is nothing but just 10 J cap, I believe. So 22 minus 12, and 7 minus 4 is nothing but just 3 K cap. Okay, so I have the force, I have the displacement. Use the definition of work, it's force dot displacement. Now how do you do dot product? In case you have forgotten, let me tell you. A vector dot B vector. A vector dot B vector is given by the x component of A into x component of B plus y component of A into y component of B plus z component of A into z component of B. That's how it works. You would have done this. This is a formula for dot product. X goes with X, Y goes with Y, Z goes with Z. Reason? Think about it. When I multiply both these terms, I dot I is 1, J dot J is 1, K dot K is 1. But I dot J or J dot I or J dot K or K dot J or I dot K or K dot I, all these are mutually perpendicular vectors. So their dot product will be 0. So they will not come in the expression. So only the x's will get multiplied with each other, the y's will get multiplied with each other, and the z's will get multiplied with each other. That's the simple way of explaining that formula. So work done will be ax bx. So minus 3 into 10 is minus 30 plus ay by. So that is 11 multiplied by 10, which is 110. All right, plus 9 3s are 27, guys. So check this out. 110 minus 30, guys, is 80, and 80 plus 27, I believe, correct? So that should give you 107 joules, and that should be also the change in the kinetic energy. All right, so 107 joules is the answer. I hope this is very, very clear. Okay, cool. So let's go ahead then. Okay, I'm not sure why it was given as 54. We need to check that. So the answer to this question is 107 joules. Alright, so let's go ahead to the next question. A bullet traveling with certain speed pierces a plank of certain thickness and comes to a halt. Okay, what should be the velocity of the bullet to be stopped by double the thickness of the plank? Okay, so let's try and understand this question first. So when this bullet goes and hits the block, it loses some energy, and it continuously is retarded because of a retarding force, and it loses all the kinetic energy, and by the time it just is about to come out of the plank, it loses everything and it stops. So there is a retarding force which is doing negative work, sucking away all the energy from that bullet. Okay, so keep that in mind, and let's do this problem by work power energy. Although please keep in mind, we can solve this problem using kinematic equations and Newton's laws also, but we are not going to do that because we are discussing work power energy. So I'm going to keep it related to work power and energy. So think of it, if this is that bullet of mass m, it has certain velocity, let's say v. Slowly it loses all the energy and it stops over here, and meanwhile what happens is on it there is a force acting on it. All right, so let's just call it F, and it makes it stop in a distance of, let's say, S. All right, so here is what I'm going to write. The net work done by all the forces is final kinetic energy minus initial kinetic energy. That's your work kinetic energy theorem. Which force is doing work? This retarding force. How much work? F into S into cos 180 degrees. Why 180 degrees? Because if you observe it carefully, you will realize that the displacement is actually here and it is opposite to the force. So that means the angle between force and displacement is 180, and anyways the work done should be negative because it is sucking away the energy. What is the final kinetic energy? 0, because it stops. And what is the initial? Well, it is half mv square. Now just do this math, so it will become minus fs is equal to minus half mv square, and now just rearrange it, so you will get 2fs, m comes down, is equal to v square. Now I'm going to use this formula for both the situations. So if I know the speed initially, 2 times force into the distance of stopping divided by mass is the velocity square. Great. So let's use this now. How do I use it? Observe. Initially the velocity was root 2. The thickness was certain thickness, let's say s. Next time the thickness is double, so s will become 2s. So here is what I'm going to do. When v is root 2, so root 2 square is nothing but 2f into s by m. Now when the speed is v, think about it, I'll just divide it by v square. So I'll have exactly similar term, and I think I can take ratio. I can take ratio, velocity square by velocity square, so it will become 2f, but this time it is 2s divided by m. So it's just the ratio of the velocity square, that's what I have divided, and you will see 2f and 2f goes off, m also goes off, in fact s and s also goes off. So what will be left over here is 2 divided by v square, correct, is nothing but, think about it, this 2 only remains, nothing else remains, I believe. So there is just 1 2 downstairs, so that 2 goes upstairs, it will become 4 is equal to v square, therefore v is equal to 2 meters per second. That's the speed of the bullet second time. So if you double the thickness, the speed has to be increased only root 2 times as compared to the previous speed. Very interesting problem, and how we have solved it using work kinetic energy theorem. So that's the answer, 2 meters per second. Let's go to the next one. Now this is interesting. The box weighs 1000 Newton. It has to be slowly moved, okay, slowly is a key word, okay, by 20 meters on a straight horizontal ground surface. Coefficient is given. What is the work done by Pandu in pulling the box by an angle of 37 degrees? So this angle is 37 degrees with the horizontal. So let's try this out, okay. Now I'll tell you why this problem is not so easy also. Because number one, you do not know how much force is applying. You'll be like, okay, if I don't know the force, how do I find it out? Because without the force, I will not be able to use force into cos theta into s is the work done. Okay, so to find the force, think about it. When you read the question carefully, you'll realize the most important word is slowly over here. The meaning of slowly is that the frictional force, which is opposing the motion, is just balanced by the Pandu's force. Yes, so there is going to be friction here and Pandu's force, but not the complete Pandu's force, because Pandu is going to pull it at an angle. That force will have 2 components. One is here and one is there. Only this component will be just balanced by frictional force. Okay, I think it's better we draw free body diagrams and then try to explain all this. So let's try this out. So what are the different forces? Well, one is over here, the force by Pandu, but this force itself, I can divide it into 2 components. One like this, since this angle is 37, this will be F cos 37, which is, think about it, cos 37 guys is 4 divided by 5, so it will become 4F by 5, and this component is going to be F sine 37, which is nothing but 3F by 5, because sine 37 is 3 by 5. Okay, so those are the forces, but apart from that, you obviously have normal force, you also have mg. Mg is 1000, that's interesting, and you also have friction, and friction will be 0.2 times of normal, which is normal by 5, because mu is given to be 0.2, so I'm going to use that fact as well. Okay, now what do we do? Since it is given that it is moving slowly, so that means acceleration is negligible, so all the forces should balance each other. Yes, it should balance each other. And let's write down all the equations that we know in y and in x. Okay, now in y direction, normal and this force, so here is what I write: y direction, normal and that force, which is 3f by 5, is equal to 1000. Lot of people think normal is going to be 1000. That's wrong. The moment there is a force at an angle, please understand normal force is going to change. So be careful about that. And a lot of people write immediately F is mu mg. No, F is not mu mg. F is mu n. And n can change depending from situation to situation. So keep that in your head. Okay. So can I do something about it? I believe nothing can be done right now. Okay. Let's see what we can do in the x-axis. Well, in the x-axis, this force is going to be equal to this friction. So I can say 4f by 5 is going to be friction, but wait a minute, friction is nothing but n by 5. I just wrote it down over here. So 5 goes, okay, so 4f is equal to n. Now if 4f is equal to n, what will I get from here? Let's put n's value as 4f, so I'll get 4f plus 3f by 5 should be nothing but 1000. And now let's rearrange this. I'll just do it over here. I hope that's fine. So this will become, take LCM, 20 plus 3, 23. So 23f by 5 is equal to 1000, and therefore f will be equal to 5000 by, this will become 5 into 1000 is 5000 divided by 23. Interesting. I have found out the force. Now the only job remaining is to find out the work done. Now what is the work done? Work done will be the force, but not the complete force, only this component. So which force? 4f by 5. So I'll write it as, or you can think of it as f into s into cos 37. It's up to you. So into cos 37, which is one and the same thing. So it will become f, which is how much? 5000 divided by 23 multiplied by displacement 20 into cos 37. It is nothing but 4 by 5. So now you can do the math. This will become 4, right? 4 4s are 16, and you can do this. It's not that difficult. So 16 into 5000 divided by 23. So that is the final answer. You can get it in decimals. I think I have put it up how much it is on the next slide, but you get the idea. The idea is the normal force is not mg, number 1. Friction is not mu mg, number 2. Force is at an angle, so only a part of the force will do work, that's number 3. And because of this word slowly, this horizontal component is just balancing the friction. That's another key point of this problem. And solving, you get the answer as 3478.2 joules. That's the answer. What a problem. What a problem. Alright. So in case you are joining in late, it's okay, just join in for the remaining problems. We are discussing drills of the previous session. These are assignment series. The PDFs are shared in the description box of the previous sessions. Alright, and all the newcomers, please take help from all the remaining VE enthusiasts, and all the VE enthusiasts, please help the new students out here. Next, okay, this one was based on integration. Alright, so you just have to integrate. I think that's how you'll get it. Remember, work is integral of the force with respect to displacement. That's something what I told you in the previous session. So what is the force? Force is 6x square plus 4x, and dx. And remember, the limits of the integration are the initial position and the final position. Now to solve this, first split it up. So let's split it up. 6, take it outside, is just integration of x square, again from 3 to 4, and the next term will be 4 is outside, and you just have x and dx, and you have 3 over here and 4 over there. Now just do the integration, it's not that difficult. X square is the integration, increase the power by 1 and divide it by the same number. So x cubed by 3, use that formula of x raised to n, right? So it will become 6x cubed by 3, but I have to put the limits, so I'll put that later on. I just keep it in mind by this symbol. So 4 x raised to 1, actually speaking it's x raised to 1. So the integration of x raised to 1, think about it, is x raised to 1 plus 1, which is x square divided by 2. Of course, let's keep it in mind, we have to substitute these values. Okay, so 6 divided by 3, I can just divide it, so that will be 2. And first put 4 over there, so it will become 4 cubed, and then put 3 over there, it will become 3 cubed. Please keep in mind, this is a common denominator, so I can very well take it outside and just cancel it out. Even if that 3 remained here, it would have eventually got cancelled out. Okay, so plus 4 divided by 2, again I can make it 2, and first put 4 here, so 4 square, and then put 3 there, it will become 3 square. Now just simplify it, you will get the answer. Okay, so 4 cube is nothing but 64, and this is nothing but 27. Again, 4 square is 16, 3 square is nothing but 9. Solve it, you will get the answer. But you get the idea how this has to be solved. The reason why we have used integration in this problem is because, understand, the force is variable. Whenever force is variable, you need to integrate, but whenever force is constant, just multiply force into displacement into cos theta. Okay, so the correct answer for this question comes out to be 88 joules. I hope. Alright, so let's go ahead. Next question, question number 7. Let's see how to do this. This block starts from here. This part is smooth, but when it comes down, there is a coefficient of friction over here, and the block starts slipping on the track from this particular point. It's given 1 meter height. So the question is, how far will it move on the rough surface? Now think about it. When it leaves from here, from rest, it has some potential energy. It will get converted into kinetic energy, and all that kinetic energy will go against whom? Friction. So let's see how to do this problem. You have to apply energy conservation from A to B, and then find velocity, and then find how far will it go. I feel that's quite far stretched. I think we can do it in one go. Yes, just one go, and I'll tell you how. See guys, if I take this line to be zero potential energy, obviously this block has some potential energy. Kinetic energy is 0 over here. When it comes down over here, the potential energy, because this line is assumed to be 0, it's 0, but kinetic energy is there. Eventually it stops. The potential energy becomes 0, even the kinetic energy becomes 0. So the obvious question is, where did this go? Obviously it has gone against friction. So friction has taken away that energy. So why can't I think that I had example 100 laddus. Those laddus correspond to energy. If I have 100 laddus, I get 100 units of energy, example. So I use that laddus and I gave it to kinetic energy. So now kinetic energy is 100 laddus, and now again those 100 laddus go against friction, lost. So why can't I say potential energy directly gets lost in terms of friction? Alright, so whatever is the gravitational potential energy is completely used up against friction. The reason why I'm taking up this problem is because many people first find the velocity and then do the next part. That is unnecessary. You won't have so much time in the exam. So you can directly use this without worrying about the kinetic energy. That's what is important. So how much potential energy does it have? M. Okay, the weight is 10. So mg h, I'll just first write it symbolically, will be equal to how much energy did friction take away? Well, think about it. It will be the frictional force into the displacement. Yeah, so whatever displacement it did into the frictional force will be the energy taken away. Please do not put a minus sign there. No, it's energy used up. I'm already talking about the loss of energy. That is positive number. So F into D. Okay. But what is F? Think about it. It is nothing but mu mg, because normal and mg will be equal in this situation. So into D. Okay. So it will become mgh is equal to mu mgd. Oh, interesting thing is mg and mg gets cancelled out. So D is nothing but h by mu. And what is h? H is given to be 1. And what is mu? I think it's 0.2. So I believe the answer should be 5 meters. That's the answer. Okay, so you don't even need this 10 Newton. You have solved it in variables as much as possible and then finally substituted the answer. What a problem. I hope you guys are enjoying this session, guys. Alright, and I hope you are understanding your mistakes. I hope you are understanding which method is better. So you guys have come here to learn. So learn all these methods. So that's the answer, 5 meters for this particular question. Let's go to the next one. Very interesting question again. So there is a 250 gram block attached on a spring of certain constant. The spring is compressed 5 centimeters shorter than its natural length, and the system is released from the position. Okay, how high does it go? Now, because of gravity, what will happen? Okay, let's just forget gravity for now. Just think, this spring has natural length. Okay, and this block is there over here. Okay, I press the block by 5 centimeters. It will be at its lowest position. Obviously, the spring has stored some energy now. I release it, zap karke it will go up. But it is attached, so it will not leave the spring. So that's very important. It's attached. In the previous session, we had to solve a problem where it just gets stuck to the spring. It's quite reverse of this. So it will go up and finally stop. And when it stops, maybe the spring is again extended. You never know. And meanwhile, when it goes up, even the gravitational potential energy will change. So there are two energies here, gravitation and spring potential. So that's the funny concept. So understand, in this problem, maybe this much over here, maybe over here, this is natural length. Example, you have compressed the spring by 5 centimeters. I believe that's what is given. Where did it go? Yes, 5 centimeters. And you are releasing it from rest over here. Okay. So why not take this line as zero gravitational potential energy line? That will be better, I feel. So this line or this block is right now having zero energy. Remember, you can take anything as zero, and now it goes up, and maybe it goes above the natural length as well, and maybe on the top, I don't know how much it goes, but let's say it goes X amount. I don't know how much is X, but let's say it goes X amount. And it goes up, stops. So again, it will come to rest. That's what is happening in this particular question. And we have been asked, what is the maximum height it goes? That is 5 plus X. So from the initial position, how high does it go? I hope you're understanding the question. So the block has been deliberately pushed down from the natural length. You release it, it goes up, and where does it stop again? So that's how it is. So what should we use? Is energy conserved? Yes. Why? No friction, no air resistance, no non-conservative forces. So let's use energy conservation. So think, in this initial situation, what and all kinds of energies are there? What and all energies are there? Think about it. Is gravitational potential energy there? No. Why? Because we assumed it to be zero. Okay. Is spring there? Spring potential energy? Yes. How much is it? It is half into K. Where is K? K is given somewhere. Yes. 100 Newton per meter. Okay. Into X. But this is centimeters. So convert it into meters. So it will be 5 divided by 100. And this will be whole square. So that's spring energy plus kinetic energy. What is kinetic energy? Zero, because it is at rest. So please remember, this is gravitational, this is spring, and this is kinetic energy. This is the total initial energy. Should be equal to the total final energy. Why? Energy is conserved. So what is the potential energy when it goes up? Here it will be M. What is M? Well, it's 0.25 kg. G is 10 into H. H is not X. It is this plus this. Yeah, be careful. So it is that plus that. So it is going to be, understand, X plus 5, you convert it into meters. So 5 divided by 100. Yes. So that's gravitational energy plus spring energy, guys. Okay, this is at natural length, it's extended by X, so spring energy will be half K. What is K? 100 into X square. Please understand, X is always measured from the natural length, plus kinetic energy is 0 because it comes to rest. That's it. If you notice, there is only one unknown in this equation. And which is that unknown? X. Everything else is known in this equation. But this will be a quadratic equation. Why? Because there is x square over here. So that's something which you should keep in mind. So if you solve the LHS, so 100 will go away, 100 will remain. So 5 divided by 100, guys, will be, oh, but there is 125. So 25 divided by 100 will become 1 by 4. And 1 by 4 into 2 will become 1 by 8. So LHS will have 1 by 8, I believe. Check it out, because 100 will go, and that 5 square will become 25, and 25 by 100 will become 1 by 4, and 4 into 2 is 8. Okay, so that's what you will get on LHS. And on the RHS side, well, you'll have again many terms. 0.25 into 10 will become 2.5x, and here you have 5 by 100, which is 20, and you have 2.5 on the top, so 2.5 divided by, that is 20 below, plus you will have 100 by 2, which is 50 x square. Now just reshuffle these equations. It's nothing but going to be a quadratic equation. Solve this quadratic equation, you will get two roots. Just check the positive one or whatever, whichever is more relevant. Alright, so just choose it properly, you will get the answer. You can try it out. If you want, I can wait. Alright, just try it out, you will see what is the answer. Come on guys, you can keep trying. I hope you have solved it. I feel that these two will get cancelled. You'll just have very simple answers. I think you'll get two values. One is 0 and one is, I believe, 0.05. I believe that is what you should get. Try it out. This is what you should get. So 0.05 meters, or basically this is nothing but 5 centimeters. So this is the answer. Obviously 0 cannot be the answer, guys. So check it away. Alright. So that is the final answer. Okay, so 5 centimeters. Let's go to the next one. I hope you guys are ready. Don't lose your energy. Be enthused, because that's our name of the channel as well. So let's do this. So this block is released, and when it is released, it will go down and stop, and the spring will also get extended. What is the speed of the block when it has moved 10 centimeters down the inclined plane? Okay, 1 second. I have to go back to the previous slide. Just 1 sec. Okay, so when the block comes down by certain distance, the question is what is the speed? And inclination is also given, mass is given, spring constant is given, box is released from rest. Okay, alright. So I feel that we should use energy conservation, because I think somewhere it is also mentioned it is smooth. So yes, here it is. It is frictionless. So definitely initial kinetic plus initial potential is final kinetic plus final potential. So I can do that. Great. So right from here to here, think about it. If the spring has extended by X amount, obviously this block would have also gone down by X amount, but height wise it has not gone down by X. No, it has not gone down by X. Think about it, because from here to here, if this much is X, you just need to worry about this much, this height, because I will need that for calculating potential energy, remember? So the angle of inclination is given to be 30. So if this angle is given to be 30 degrees, think about it, how much will this height be? It will be X sine 30. So it will be X sine 30, but how much is sine 30? It's half. So it will be X divided by 2. Alright, so the height by which it comes down is X by 2. I'm going to need that, so that's why I calculated it and kept it. Okay, now the initial position, when it started from here, it started from rest. But when it finally came down over there, yes, think about it, it had some velocity. That's in fact something what we want to find. So what would be an energy equation? Initial kinetic energy 0 plus initial spring energy 0, because the spring was initially unstretched. Look at this word, it was unstretched, so 0 spring energy. So kinetic energy is 0, spring energy is also 0. Gravitational energy, well, it's up to you where you want to take 0 height. So somebody might say, okay sir, I'm going to take this height as my 0 potential energy line. It's okay, you can take that as your 0 potential energy line. So with respect to that, you have some potential energy. How much is it? M into G into H. And how much is H? Well, it is X by 2. And do I know the value of X? Yes. Look at this. This is nothing but X, which is 0.1 meter. So H will be, think about it, X by 2, that is 0.1 divided by 2. So I'm going to substitute that over here. So 0.1 divided by 2, okay, is equal to, so this is gravitational energy. So I've done everything systematically, guys. Everything is there in the problem. You just need to identify where it is. Finally, when it comes down, the kinetic energy is half into mass into speed square plus spring energy Well, that is half K, that's 128 multiplied by X square. So X is given to me, I think, yes, X is 0.1. So 0.1 square plus gravitational energy when it comes down will be 0. Alright, so that's what it is. So this is kinetic energy, this is again spring, and this is gravitational potential energy. Same order I have followed. Now you just have to solve this, guys. So 2 cancels, 10 into 0.1 is just 1, and here 2 again cancels, you will get V square. Alright, and this 128 divided by 2 is going to be 64, and that is 0.1 square, so it is going to be by 100. So just solve this and you should get the answer for velocity. Okay, so that's how you solve this problem. Very simple. The spring energy and gravitational potential energy and the kinetic energy sum should be constant because it's a smooth surface, so you can conserve energy. And when you solve it, you should get the answer as roughly around 0.6 meters per second. Okay, so that's a rough answer that you get. I hope this is fine and you have understood all the discussions what we did today. Very good problems. These will help you crack JEE Advanced as well as mains as well as bits. If you want to crack, you want to get a good college, you want to get into NIT, you have to solve these questions. So do not forget to join our Telegram group so that you get all the assignments on time, all the important notifications, updates, whatever we have to tell on time on this official Telegram group. Alright, so the link is also there in the bio below. And if you have loved these problems, if you have loved my explanations, do not forget to like it, because remember, that's the fees of this channel, guys. Your likes, your love, your support. And all the newcomers out here, please do not forget to subscribe. Alright, so that's it for today, guys. I hope I'll see you again tonight at 7 p.m. where we are going to discuss the next part of the chapter. Alright, so see you, take care, bye bye, stay home and stay safe. Bye bye.